Welcome to today's webinar about generative design and topology optimization. I'd like to welcome you. I set up an agenda. My name is Urs Simler. First, I will talk a little bit about me, about GIA Informatik AG. I'm working for this company. Then let's have a little overview about generative design compared to topology optimization, and the most of the time we will see live demonstration in a topology optimization solution, which also provides some capabilities to do, let's say, some generative design. And at the end we'll have time to answer your questions. So if you have any questions, please write them into the question panel in the webinar application. Okay, here is the presenter. My name is Urs Simler. I'm working for GIA Informatik. I'm doing quite a lot of simulation stuff. Before I started working at GIA Informatik, I was for 20 years at PTC as a simulation specialist, and I'd like to show you some news about topology optimization and generative design. This is our sales guy at GIA called Daniel Losley. If you have any further questions, here are his coordinates. And by the way, I also have a YouTube channel. If you're interested, you can subscribe for it. Here is the link for it. Okay, some few words about GIA Informatik. We're located in the middle of Switzerland. Our company has around 140 people. We are a software partner of SAP, and in the, let's say, CAD PLM environment, our main partner is PTC. And of course, in the environment of PTC products, there are also some interesting products, additional products for simulation and for other stuff. And we are reseller of topology optimization from CAESS. This is a Slovenian company. And we also reseller of Elaborate. They provide software for electrical clearance and creep pitch analysis. And we also sell solutions from TechSoft from Austria and Software Factory from Germany, Munich. We have an own training center in Oftringen, and let's say our people are quite experienced. Okay, but let's have a look at our theme today, generative design compared to topology optimization. What are common similarities and what are the differences? I would say, why do we talk right now quite a lot about generative design? I think one reason is because every company or many companies, they have 3D printers in-house and they want to use it, they want to feed it with new material, with bionic structures coming out from topology optimization or generative design. And of course, we'll see quite a lot of cloud-based solutions, and the cloud-based solution, they provide infinite computing power, and that's also a reason that we talk quite a lot about generative design. Okay, I think right now we are somewhere in that region with our expectations, with our attention to generative design. We'll see later on, PTC is also coming out with new solutions at the end of that year. We'll talk about that a little bit later. But what is generative design? I would say it's topology optimization 2.1 or 2.2. With that solution, we are able to create, let's say, infinite variants of a design, and we can also take into account different parameters, spatial conditions, manufacturing processes, cost targets, material conditions, and then that kind of stuff can all be taken into account to create thousands of variants of our design. Of course, for that reason, we need quite a lot of power. Therefore, we need a cloud solution. And let's say the difference and the similarities to topology optimizations are here, but they also have some common targets. Both of them, they want to create more efficient, better components, lightweight components, stiffer components, and that kind of stuff. And I would say generative design builds on the principle of topology optimization. And if I look at, let's say, some historic data, topology optimization is on the market for a long time, 30 years, but generative design came out, let's say, with cloud solutions starting around 2015. The topology optimization is more desktop solution, and generative design is in many cases it's cloud-based solution because we need a lot of simulation power. And I would say topology optimization brings out traditional topology optimization one single optimized shaped. And if you compare it to generative design, there we get infinite number of designs. And of course, both methods, they take into account manufacturing methods. There is no difference between them. And I would say topology optimization is more user-driven and generative design is more computer-driven solution. And of course, I think that's a nice advantage of generative design. Quite a lot of them are using also AR, artificial intelligence. Of course, in one or in two pictures, I would say the old way, yes, it's not that old, but it's a traditional way. There is one man, one computer, and you get one optimized design for topology optimization. And if you're looking at generative design, you must have a cloud solution. You must feed your cloud solution with artificial intelligence algorithms and of course with some CAD geometry, and then at the end of the day you'll get many variants of your design. Incomplete list about these products for topology optimization and generative design. Let's talk a little bit about Creo Solutions. I mean, we have for 3 years, we have topology optimization from VRNT in Creo Parametric, and 2 years ago PTC bought the company Frustum, and their product will be integrated in Creo 7.0.2, coming out in about 6 months. And beside the PTC product, we have also additional independent products like ProTop with a Creo gateway since 2015, or we have Inspire on generative design, OptiStruct, Autodesk, Tosca, and so on. And I think this is a very incomplete list. There are many products out on the market. But is there maybe a possibility to use both advantages, or the advantages of both technologies? I think yes. With ProTop we can do that, and I think we can do that also with different source data coming out from different CAD systems, because ProTop can be fed with simulation data from PTC or from CATIA or from SolidWorks or Siemens NX or what else. And I think with the help of the intuitive session manager, which came out in the new version, we can really go into direction generative design, we can really create many variants, and it's quite easy to handle them. I will show that quite soon in a live demonstration. And I think the advantage of topology optimization is that we really can that we really have traceable optimization process. We can take influence on that one. And I think one important thing is many companies, they do not wanna, let's say, send their intellectual properties to to the cloud. So they want to keep their intellectual properties, and I think ProTop can be fed with CAD data from many solutions. You have a crystal clear cost license structure, and by the way, you have a small software factory which can react very quickly on new customer requests. And by the way, we'll see the solution is very quick. I'm working with an old laptop from Lenovo, P50, 3.5-year-old laptop. And we want to have a look at an example where we want to build several variants of a bracket which will be loaded here in that directions. We have 2 load sets, and which is, let's say, constrained here in that region. And of course, at the end of the day, if we would have had a little bit more time, we'll get this kind of variants here. But let's start from scratch with our CAD system, Creo Parametric. I opened Creo 6.0, and here in Creo 6.0 I designed my room for my optimized part, and in the Creo Simulate application, in the FEM mode, I just created the simulation features here. I created some loads and constraints, so it's constrained there on that surface. It's loaded in that direction. This is one load case, and it's also loaded in those 2 directions. And of course here I set it up mesh control. The maximum mesh size should be 1.75 millimeters. I assigned here a material here, and I assigned a special material for so-called volume regions. This volume region should not be optimized. This is, let's say, material which cannot be removed later on from the topology optimization. I'm going to mesh my component. This is taking about 10 seconds. And we'll see here quite a dense mesh. It's needed for topology optimization. This is not Creo Simulate native mode. This is FEM mode where we create that. And with the help, let's say, of a Pro TK we can also, let's say, make the gateway with ProTop. I just brought in right now these buttons here. I could push just that button to send my data to the solution, but I will do it by hand, as you can do it also with other CAD system. Here I just have to write out a input disk with linear elements. I will write out structural FEM format, and here I say, okay, this should be done in a folder called, what should I call it? I call it Max. Okay. And now a file will be written out. I'm going for my folder here. It's under here on the data, and we see, okay, there a folder Max is created, and I'm getting here an FNF file. This is a, let's say, a traditional input disk for finite element solution. At the beginning you have some nodes, then you have some elements, and at the end you have, let's say, the forces, constraints, and material information. And this file can be taken now by topology optimization solution called ProTop 6.0. And here I just open a new project here. Under the folder Max, I'm going to open my FNF file, and this will be imported here. So I'm getting information about my design room, about the loadings, about the constraints, material information, and quite soon I will bring in some additional information like technological constraints or all that kind of stuff. Here we can have a project folder, commands can be taken out and so on. It's quite easy to use that solution. And the most important thing is here the session manager, because with this session manager it's really very, very easy to organize my variants and to go into the direction of, let's say, generative design. So the first thing I'm going to do, I'm bringing in a very easy technological constraint, and with this technology constraint I want to do the following thing here. One moment, I want to create one here. Okay, and it should be a plane symmetry here. Which volume should be symmetric? I mean, let's say the free volume, call it now in green, should be symmetric to a specific axis, and as you can see it should be the x-axis. We see here this purple plane, blue plane, it indicates, let's say, the plane symmetry. Okay, so this is our initial, let's say, design, because at the end we want to have all our variants symmetric. I'm going for my session manager and I'm creating here a duplication of the active session here, and I call it, maybe this is 3D printing, and this should be a very coarse solution here. Okay, and I'm just hitting here the button. I want to optimize here. I want to perform a topology optimization. Just started it here. I'm going to take away the material quite aggressively, and in that region here I can say, okay, I want to see the geometry, or I want to see the stresses, I want to see the displacement here. So it's already calculating. Here are the stresses, and depending, let's say, on the high stresses, Creo, now it's ProTop, cuts away, let's say, the regions not needed here. Of course, these regions are not needed for stiffness. Also, this material is not needed for stiffness, but the gray material cannot be cut away. So every 10 seconds, new cut will be done, and let's say the number of equations are getting less and less and less. And my initial target is I want to reduce the free area to about 50%. I want to bring it a little bit more down because I'm quite close to 50%. My target should be right now, I want to have 20% here, around that one. And you see, when I'm looking maybe here from front, by creating a cross-section, okay, I can see in my cross-section, I can move that during the optimization process to see what happens. In my component, I can see, okay, a bionic design will be created, and for sure this kind of design has to be 3D printed. Okay, so I'm deleting my cross-section, and we can see right now we are around 25% after 12 loops. And the design looks as follows here. We can also bring in our, let's say, stress legend here to see where we do have the high stresses, where we do have the low stresses here. And I would recommend at the end of the optimization, you should take a little bit less aggressivity here, Yellow means less aggressive, and here red means more aggressive with these two sliders. Okay, so I'm taking it quite smooth away, and I say, okay, now I want to stop my optimization process. And I think it's also quite important that you see during the optimization what's going on, that you can see the stresses, that you can really influence the optimization process. If you have a generative design solution, you have no clue what's going on behind the scenes. So right now I have my, let's say, core 3D printable component, but I want to take out some more material, but for that reason I would say I need, let's say here, more elements, and therefore I also have the capabilities within Protop to do a mesh refinement. I do not have to go back for my CAD system. I can redefine the mesh here. With these numbers I say, okay, I want to subdivide the elements above an edge length of 1 millimeter, but I don't want to use more than 7.1 gig of RAM. And now the redefinition will be done, and I'm getting here a new session. So automatically a new instance will be created in my session manager. So I can always go back for the old session with the coarse elements, but now I want to proceed with the dense element. The meshing process is still on the way. Maybe just let's have a look here at that elements in that area here. Okay, and quite soon we'll see that these elements will be divided. I hope. Yes, it's doing it right now. Okay, now I have a much more dense mesh, and I will do the optimization. I will proceed with the optimization, and I will bring down, let's say, my target to about 12-13%. And at the beginning I say, okay, I want to cut out much more. Going here maybe back for the geometry. Yes, we can see the geometry here. But now we have the design room with very, very dense elements. And of course, stresses will be created quite soon. We'll see that the cycle time is coming up a little bit because our number of equations increased. And we see right now the stresses, and now every about 25 seconds, let's say, another cut will be done. I'm cutting away quite aggressive right now. Let's do it a little bit smoother here. I'm using my custom scale maybe to have stresses between 0 and 100 megapascal. Let's go here a little bit up. You can also use the mouse wheel to do that. Okay. So you see right now I was in between. I was a little bit very aggressive, so it cut away this bar here, but that doesn't matter. And I can see what's going on right now. Okay, now a design cycle takes around 15 seconds, and I'm getting here, let's say, a new instance of my geometry. Of course, in reality, you have to spend a little bit more time on that, but I will show you later on, let's say, a solution which took about maybe 40 minutes to create later on. But I'm quite happy now with my new instance here. It looks quite interesting. And I'm stopping here, let's say, the solution. You can stop it here by a board immediately, or now it finished, let's say, the last cycle. Okay, I'm having here right now a new solution. This has to be 3D printed. But now I want to create an additional thing, instance. I'm going for my home tab. I'm going here for my initial variant, and I'm copying the initial variant. I'm duplicating it. So okay, this may be the variant I want to create with a laser option. Okay, and therefore I'm bringing in here additional technological constraints by maybe copying one. I can say, okay, I want to bring in an additional constraint, which is, oh, I don't know what here, I do not understand this option. Therefore, I have a nice help which explains everything to me. And I'd like to create here a bi-directional open constraint. Okay, that means it can be milled or lasered. So I'm doing here bidirectional open. Of course here that one bidirectional open. And I want to use the same constraint data. No, not really the same because my plane has to be changed. It has to be perpendicular to, let's say, this plane here. Okay, and with this new technological constraint, I'm going back here for my topology optimization and I run it again. Maybe you mentioned here that I still have or have again, let's say, the coarse mesh in order to, let's say, pre-optimize my component. Later on, if I really want to optimize, then I'm bringing in additional dense mesh on it. Of course, we see here the stresses, and at the beginning I want to cut away the material quite aggressively. Okay, this is done right now, but now you see, okay, the cuts they are here in an order that we have like a laser option here. So the cuts, or it will be milled, or it will, I would say, I'm using a laser to take out the material. Okay, our target should be, we want to go direction to 35%, something around that one here. I'm reducing the aggressivity, and I can see here some cuts, of course, and later on to create such a component will be quite easy because you just can, let's say, bring in sketches with that cut shapes in your CAD system. Okay, we have here the solution. We can bring down maybe the stresses here a little bit, or the legend levels with my mouse wheel, and I can really see what's going on in my part. Of course, it makes sense to do it a little bit less aggressive in order to get a nice solution. And of course, here the sliders are moved to a position depending, let's say, also on the density of your mesh inside the component. But we see a very interesting solution here which can be milled. And I would say, yes, we understood this principle. I'm going to stop this run here, or this variation creation. It's doing the last cycle. And I have here a nice solution. Okay, but now I want to create a solution which can be costed. Going back to my session manager, and I'm creating an additional copy here. I say, okay, this guy here is casting. Oh, casting, something like that. Let's delete this information. Okay, and you see here, okay, the old solution. But casting is right now with the standard here. Okay. If I would start here with my optimization model, it would start here with, let's say, the pre-optimized model from the laser option, this one here. But by, let's say, taking here the configure design and making it current, it will start, let's say, from scratch again, of course, by using also the technology constraints. And I'm going to change now my bidirectional open technology constraint to a constraint for a casting. I can see here in that nice help that I should use B unidirectional open. So quite clear for me, take here B unidirectional open. And the constraint data is nearly the same. The only thing what I can bring in is here additional draft angle. And maybe as an additional feature here, I'm moving up here, let's say, my plane for the draft angle to a level of 7.5 millimeter. Therefore, I'm creating here a new coordinate system, and I'm moving that coordinate system by 7.5 millimeters here. Okay, you see it moved here, 7.5 millimeter, and I shouldn't forget to activate the new coordinate system. Okay, now here, starting from that plane, we should see, let's say, draft angles of 5 millimeters. Let's check that by starting topology optimization again with the same target, starting from scratch with the full model. We will see that it's cutting away. Maybe we can see it a little bit better from that view. Okay, let's use that view. Let's see maybe the displacement. Let's see the geometry here. And now it should cut away a little bit. Let's do it a little bit more aggressive at the beginning. Okay, and here we can see, okay, there is draft angle. Okay, now we see it better. Here we see, okay, we have the draft angle until here, or here we see it better, here and here. Okay, and of course, if you are watching our part from top, now we are watching from top, we see that we can, let's say, pull away, let's say, the casting form here. Okay, so also interesting geometry will be created. Let's do it a little bit less aggressive. Okay, and if you watch from bottom or from top, we see very, very interesting bionic shapes. Okay, geometry will be created. Be around 39%. Oh, that goes very, very fast. Okay. And I would say we're going further down to a target of 31%. Of course, you could also use as a target the boundary stresses on, let's say, the yellow surfaces here, or you could set as a target displacement on your part. Okay, we have here this kind of solution. Okay, and we pause our optimization process. Of course, an additional mesh refinement can be brought on that geometry and do, let's say, the final optimization. But now I want to create additional variants here because I have a 3D printer. I want to use maybe some called Lattice structures. And to be able to do that, I'm going back for my session manager. I'm activating my initial, let's say, design room, and I'm copying the initial design room. Okay, and this should be, let's say, a 2D Lattice variant. Okay, because I started from initial here on the optimization model, I only have my plane symmetry constraint. Here I could also suppress or activate them. Now this plane symmetry is activated, it's green, and I'm creating a new so-called part configuration. Here I have a capability to create solid, shells, and lattice configuration. I'm using right now a lattice configuration. And which kind of lattice do I want to use for this green region? This one. no, this doesn't make sense. I want to use here a maybe 2D honeycomb solution. I'm showing then. Oh, in that direction doesn't make any sense. So I spin it around the A-axis. Then it looks like that here. And as soon as I'm bringing in here in that direction a 0 value, an extrusion will be created. And maybe I'm using a cell size of 15 to 15 millimeters. Okay, it's looking like that here, looking from top. And of course here I'd like to have here a closed loop of that cell. Therefore I should move my coordinate system a little bit, and that can be easily done by bringing in here a cell translate of, let's try 8 millimeters. Okay, and this looks quite nice. I'm defining maybe here a maximum thickness. This is the cell thickness of 5 millimeters, and by bringing in a minimum thickness limit of 0, let's say the cell can be taken away. Right now I see the maximum value here, and by bringing out the initial thickness parameters I can, let's say, bring a little bit less material for the starting position. I'm starting with the full model here, okay, and now I'm going for my will be cancelled. I have to, okay, one moment, common data, configuration data. Now everything should be okay. 05, okay, okay. Everything okay, and I can see here on the current design, I'm analyzing it, my current design, I can see my configured design, I can make it current. Okay, and I'm starting again my optimization here. The target should be around 24%, and I'm running the cycle. Of course, now my design room includes around 50 or 60%, 58% of the elements, so my calculation will not take that long. So one cycle takes around 10 seconds, but quite usual, quite often when you have these lattice structures, it takes, let's say, at the beginning 2 or 3 cycles until you really see where it's starting to cut, because it's quite difficult to find out for pro-top where is, let's say, where are the areas where he can start to cut away the material here. Of course, you see here a slight change of the volume of the part of the free area, and quite soon, I hope. I cross my fingers. Yes, I think it starts right now here. It takes away again the material in that region. Of course, in that region no material is needed. Okay, next step. Local cycle 7, taking away additional material. Now, come on. Now you see here the thickness of the lattice structure is removed more and more and more. And of course here during simulation we can see the stresses or displacement or what else. And we are creating right now a optimized part with a 2D honeycomb lattice structure. Okay, target 24%. Let's be a little bit more careful. Okay, and let's watch here the change of my design. And I think quite important is here, really you can see what's going on in that optimization. You can take influence. I mean, during the optimization, you can change your target. You can go back to a certain variant or a certain cycle and starting again from this cycle. So there is really a big flexibility, and as I mentioned before, you do not need a cloud solution, infinite calculation power. An old laptop with at least 16 gig of RAM, this is enough. Now we see, okay, how Protop is cutting away the material, and it's creating in that area here quite interesting lattice structures. Okay, I think we understood that thing, and I'm stopping here again, and I want to do the last variant here. Therefore, I'm going back for my session manager. I'm duplicating that one. Okay, and I'm changing here the power configuration. I want to use another lattice. I want to use the 3D lattice, this one here, with switch options, something like that. Let's do here 0, and let's show it. Yes. Is the 3D? Yes, I forgot here to bring in that value because I want to have really 3D. Okay, and now it's looking a little bit more interesting. Okay, and I just want to use this configuration to start over. Okay, therefore I'm going for my current design. I'm going to analyze it. We'll see, let's say, the pre-optimized design from the last session. By clicking on that one, configure design I want to start, and I want to make that current. We'll see, okay, that's looking quite interesting, and therefore I'm going back for my optimization tab, and I'm running the cycle again. Okay, and I will see, let's say, the same behavior here. In the meanwhile, I'm going back for my Creo Parametric and just want to show you that one here. So I did the optimization in Protop. I loaded here, let's say, the half of my faceted design, and by using a freestyle feature, I created, let's say, this area here. And of course, then I made a solidify. I mirrored it, and I did quite a lot of no, not a lot of. It took me about half an hour to create out of that faceted model, this, let's say, freestyle model. And also this freestyle model, I was taking it into Creo Simulate. And here under, where is it? Under applications, a moment, simulate here. We can see also the results. In the meanwhile, Protop cutting away here. Let's say the areas not needed. Oh, it took a while, so I can go back for Creo Parametric and maybe show that was the wrong one. I went to the old topology optimization of Creo Parametric. I want to go for Creo Simulate. This is the button I was searching for. Okay, and here, out of my analysis I created, I can see here also the results. Let's do here the results. Oops, that was the wrong mode. This is live demonstration, so I have to change the mode here to native mode. And then in native mode I can see here the results. Sorry for that confusion here. And let's see here maybe the stress results. They will be loaded. Okay. This is let's say, the validation calculation in Creo Simulate. But in the meanwhile, I hope right now, yes, it's cutting away the materials, and we are quite close to our target of 24%. And here we see, let's say, these interesting lattice structures. Okay, but that's, I would say, all for this kind of stuff. Doing generative design with the topology optimization solution from ProTop. So I'm stopping this solution, and I think you saw that it's quite intuitive creating this different solution by using this session manager. And with the session manager here, you really see what's going on, and you can take, let's say, additional projects, copying them and starting over with them. As I do it right now, I'm opening a project here, open project. I did that, I think it was Tuesday. I called it live, so opening the live project, and here we also have the session manager. And I see this is, let's say, the old solution, or this solution I showed you before in Creo Parametric. This is that solution. So I just click on that one. It's active. Okay. And I say right now, let's go for optimization. And then I see, let's say, this behavior, and I can start over. I can bring in, I can add here material or all that kind of stuff I want to do is possible. So I run the cycles again, and I say, okay, I want to create here maybe a new instance with more material. Therefore, we'll see quite soon an additional step here, and I hope that we'll see that it's adding material. It is taking maybe 20 seconds. And so it's really very, very, very easy to handle all these different variants here. It's running. Let's wait another 5-10 seconds. Come on. Let's do that cycle. This is really live. Here I can abort it if it's taking too long, but I'm waiting another 5 seconds. 1, 2, 3, 4, 5. So I'm aborting this process. It's taking a little bit longer. Don't know why. Okay. And I'm going back for the Home tab. I'm opening, let's say, the project Max. Okay, and in the session manager here I can see maybe the initial guy here or the casting guy. Or which one? Laser session. I'm taking that one. This one I like it, so I'm activating it. I just want to bring over that geometry here. That geometry should be taken over to, or should be taken back to the CAD system. I just say, okay, I want to smooth the surfaces. Okay, checking those surfaces. Okay, I'm zooming in a little bit. I'm selecting the surfaces and I'm going to remove some peaks. Okay, refine some triangles. Okay, smoothing the surfaces a little bit. And simplifying the surfaces a little bit. So, okay, I'm satisfied with that one. Okay, and I'm taking the step to export, let's say, the surfaces. I'm just say, okay, I'm checking them, and I wanna export them. Export surface max STL save on the data. So now I hope it's created, and let's create also a OBJ file called on the data. Oh, it's going to max. So now I see why it didn't work. Okay. So stupid guy. Sorry for the confusion. Export surface again for STL. And let's do maybe so max STL, and on the data it will be created right now. Now it worked. And I'm going back for the CAD system. Okay, and here I could just say, okay, I want to open all objects. And here we see the STL file. Okay, a new component will be created. Of course, if I had taken, let's say, the dense mesh, it would look much better. But with the help of that one, I could, let's say, recreate my part, or I can do the following thing here. I'm creating a new component, and I'm going for the freestyle option here, and under the freestyle option, here there is a possibility to import the OBJ file. Okay, and this guy will be taken into Creo Parametric, and then you can, let's say, take them and delete some surfaces, move some points with the freestyle option. This is also taking about 2 or 3 minutes. Therefore, we are at the end of the live confusing demonstration at the end. We saw how we can really create a lot of variants in ProTop with the session manager, and that we really have a solution where we can do topology optimization and generative design on a simple desktop without sending, let's say, our critical data to a cloud solution. There another information, GIA will also hold or will do some additional live workshops, online workshops, because of the Corona crisis. If you're interested, just send me an email. These, let's say, trainings are unfortunately in German. If you have really a lot of attendees, we can do that also in English. But that brings me to the questions. Are there so far any questions about the topics shown in the webinar? Please use your question panel to do some questioning here. In the meanwhile, I can maybe watch for this guy here, still creating the surface as it created it right now. Of course, right now we have quite a lot of let's say small cuts inside, but I would say it's not that bad here. And with that import in freestyle here, we can do, let's say, the validation calculation. We can really use that guy for further investigations. Okay. Let's go back for the PowerPoint here. Let's have a look at the questions. There are questions: how many processor cores can be used efficiently? Right now I'm using all, let's say, the cores. I'm not sure whether there are some options where you can say I just want to use some of them, but especially during, let's say, solving of the equation system, all of the cores will be used, and that's the reason why this solution is very quick on even on an old laptop, and therefore I think it's really a very cool solution. And another thing is it never crashes. I'm working right now for 3 years and it never ever crashed. You can do everything with it. Yes, that's all. Any further questions? Doesn't seem to look like. If you have any questions, maybe send me an email. And therefore I want to, let's say, finish the webinar. We are 2 minutes in advance, but that's no problem. So I'd like to thank you for your time. I hope the webinar was interesting, that you saw the ProTop solution, that you really can do topology optimization and generative design within one solution, and you do not have to send, let's say, your intellectual properties to a cloud solution. That's all from my side. I wish you a very nice afternoon. And one thing very important is stay safe and sound, stay healthy, and in Switzerland we have to stay at home. As I guess all of you stay in your home office, and then this crisis will be over in a few weeks. Thank you very much for your time. It was a pleasure for me to present to you, and I'm looking forward to hear from you soon. Thanks again. Stay safe and sound. Arrivederci. A bientôt. Auf Wiedersehen.